What's going on, everybody? Welcome back to my YouTube channel. Well, we have this nice and beautiful Olympiad question on the board that we're going to be solving. And the question says, given that x is a real number such that x plus 2 raised to the power of 4 plus x plus 1 raised to the power of 4 is equal to 17, find the value of x. Well, I'm going to be applying substitution to solve this question. But in order for me to do that, I need to simplify this further to look like this. For example, x plus 2 can be written as x plus 1 raised to the power of 4. So I've been able to simplify this like this. Plus, now let's write x plus 1 raised to the power of 4 equal to 17. Now, I'm going to be applying the substitution now. I have x plus 1 here, and I also have x plus 1 here. So I can say, let x plus 1 be equal to p. So that means wherever I see x plus 1, I'm going to be putting p there. So let's go ahead and substitute that here. So this expression now becomes p plus 1 raised to the power of 4 plus this expression becomes p raised to the power of 4 equal to 17. Now let's go ahead and use binomial expansion to expand this. So using binomial expansion to expand this, I'm going to be having p to the power of 4 plus 4p to the power of 3 plus 6p to the power of 2 plus 4p plus 1 plus p to the power 4 equal to 17. So you notice that the binomial expansion ends here. And now this is just plus p to the power 4, which we have here. Now notice that I have p to the power 4 plus p to the power 4, which gives 2p to the power 4. Now writing the other values, I have plus 4p to the power 3 plus 6p to the power 2 plus 4p. Now I have plus 1. I'm going to be moving 17 to the left hand side so that it becomes negative 17. Now nothing is remaining on the right, so equal to 0. So 1 minus 17 is going to give me negative 16. So we have 2p to the power 4 plus 4p to the power 3 plus 6p to the power 2 plus 4p minus 16 equal to 0. Now, looking at this expression, you notice that 2 can actually divide. So let's go ahead and divide through by 2. So I have p to the power 4 dividing through by 2 plus 2p to the power 3 plus 3p to the power 2 plus 2p minus 8 equal to 0. Now we have a quartic equation. Now I'm going to be using the factor theorem to solve this quartic equation. Now when I substitute p equal to 1 into this expression, you notice that I'm going to be getting 0. So therefore, p minus 1 is a factor, because when I move 1 to the left hand side, it becomes p minus 1. So that is what I have as a factor. And now using this expression to divide this factor, I'm going to be having a cubic equation of p to the power 3 plus 3p to the power 2 plus 6p plus 8 equal to 0. Very good. Now I have a cubic equation here, which can also be factorized. So let's go ahead and factor this cubic equation. Substituting p to be equal to negative 2 into this cubic equation, I'm going to be having 0. Now moving negative 2 to the left, it becomes p plus 2. That means p plus 2 is a factor to this cubic equation. So we're going to be substituting that. So we have p minus 1. This is what we have before. Now our following factor is p plus 2, which is a factor to this cubic equation. Now, dividing this cubic equation by p plus 2, I'm going to be having a quadratic equation of p squared plus p plus 4 equal to 0. Now, let's focus on this quadratic equation. Remember that the question said we are to look for the real values of x. So I want to check if we're going to be having a real value from this quadratic equation. Now, using the discriminant, I have discriminant to be equal to b squared minus 4ac. Now, let's go ahead and substitute. So, discriminant equal to b is 1, that's the coefficient of p. So, 1 squared minus 4 times a. What is a? A is 1 times c. And what is c? C is 4. So, this becomes 1 minus 4 times 1 times 4 is 16. Now notice that the discriminant is negative. So we're not going to be having real solution from here. So let's say no real solution. That means we're going to be focusing on the other two factors. Let's go ahead and do that. For those other two factors, we're going to be putting them into two cases. So case 1 is the first factor, which is p minus 1 equal to 0. And for the second factor, we're going to be calling that case 2, and that is p plus 2 equal to 0. So from the first case, you notice that p will be equal to 1. And this happens when moving negative 1 to the right-hand side. And for the second case, moving plus 2 to the right, I'm going to be having p to be equal to negative 2. Now remember that we said, let me write it here, recall that we said x plus 1 be equal to p. That's what we substituted, right? Cool. So let's go ahead and try with the first case. So for the first case, that is when p is equal to 1, I'm going to be substituting 1 for p here. So x plus 1 is equal to p is 1. Now moving 1 to the right, I'm going to be having x to be equal to 1 minus 1, making the value of x to be equal to 0. That is from the first case. Now for the second case, we're also using the same substitution of x plus 1 equal to p. Now p here is negative 2. So substituting the value of p, which is negative 2, I'm going to be moving plus 1 to the right hand side. Now let's move plus 1 to the right hand side. So we have x to be equal to negative 2. As plus 1 crosses to the right, it becomes minus 1. So making the value of x to be equal to negative 3. So we have two values of x. X is equal to 0 or x is equal to negative 3. So these are the only real solutions for x. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.